Alright, so when the popular streaming service Netflix was founded in 1997, they were a mail-order DVD subscription service. Here's a little bit of history from my world for you in case you didn't know that. Did you know that about Netflix? Like, I grew up in the Blockbuster era where you went to the video store and you rented, like, DVDs or VHSs, depending on what time period you're in. Like, you took it home. If you didn't return it back, they charged you late fees. Then, during the end of the Blockbuster era, Netflix, you, like, picked out the videos that you wanted to watch, and you sent that in, and they would mail it to you in the mail, so you get DVDs in the mail, and then you would watch them, and then they'd give you an envelope to send them back, and you'd send them back. So that's how Netflix started, in case you didn't know. Back from the dark ages, back when I was probably in like 4th or 5th grade right there. That's what we did. Now, obviously, Netflix is huge and it's not like this at all for the DVD subscription service, but that's where it got started. So, as the demand for renting DVDs rapidly diminished, Netflix transitioned into a streaming service. In 2007, T=0, Netflix launched their new streaming service with 7.32 million subscribers. By 2015, T=8, Netflix had grown to 70.83 million subscribers. The number of Netflix subscribers can be modeled as by the function N of T equals A times B to the T, where N of T is the number of subscribers in millions for year T, and T is the number of years since the initial launch of Netflix streaming service in 2007. So, 2007 probably sounds old to you guys. Seems like just like no time ago to me. Use the given data to write two equations that can be used to find the values of constants A and B in the expression for N of T. So we've done a few of these that I kind of put in like our test prep stuff for this, and some of my test questions looked like this on your FRQs. So he has a tip right here. Write out the two coordinates from the given information. Time is almost always the input. It's the input here. So we're looking right here. In 2007, you had 7.3 million subscribers. So we're going to write a point for that. 2007 is going to be time equals 0, and we got 7.32 million subscribers. And then 2015 is T equals 8, and you had 70.83. So we got 70.83. So they are asking for an exponential equation right here. N of T is the number of subscribers. T is your time, right? So like when we're looking at these equations here, this is your T, this is your N of T. You don't necessarily have to label that, but if you want. T is like your X coordinate, and N of T is your Y coordinate. So to write your two equations, what you're going to do is you're going to plug in the point into that expression. So like for 0, 7.32, you're going to put 7.32 equals A times B to the 0. And then your second equation, you're going to use the other point. 70.83 equals A times B to the 8. Now, he over here, or any questions on writing those two equations, you're not doing anything with those equations yet. You're just writing, right? So you're just taking the points and plugging it into the form that they give you. On some of these, you can just solve it with a regression, right? If whatever form they give you right here If that is the form of one of your regressions, you can just use a regression, which is what I would suggest doing for this. So if we grab our calculators real quick, let me grab mine here. Because number 2 is also calculator active. If we grab our calculators, how do I put data into the calculator? Stat, edit, and I'm going to clear out whatever is here. Clear, enter, or just delete all of those. Just don't delete L1 and L2. There. And then I'm just going to put in 0 and 8 and 7.32, 70.83. Just make sure you got your numbers in there correctly. Now how do I do the regression? LinReg's going to give me a line. What do I want for this one? I want XPreg because I want exponential regression. So I'm going to go down here to EXPReg, L1, L2. It's best to just go ahead and store this in Y1 every time. You may or may not need it, but it'll be there if you do need it. So for store regression equation, how do I get to Y1? Alpha trace, Y1, and then calculate. And so A is 7.32. And B equals 1.328. Now, you want that stored in your calculator. You want to keep the whole decimal as far as working out problems, but as far as what you write down, 1.328 is fine for that. Now, this can be solved by hand. It should make sense that B to the 0 right here is going to be just 1, and so A is going to equal 7.32. It's just that initial value. And then we could plug that in and solve it by hand. But if it's one that you can do a regression for, just do the regression on it. It'll probably be faster and easier. There, we're going to look at one also that you cannot do the regression for. So I'll show you what that looks like in a minute. Now, B is going to be about the average rate of change. And I've given you some of these on test. Average rate of change is slope between the endpoints. It's not exponential. It's not quadratic. They could ask you this on any question, right? So if it asks you to find average rate of change, it's asking you about slope between the endpoints. And they've given you slope formula. He's giving you slope formula over here as a note. So it says use the given data to find the average rate of change in the number of Netflix subscribers in millions of people per year from t equals 0 to t equals 8 years. Express your answer as a decimal approximation. Show the computations that lead to your answer. So you had the point 0, 7.32. You also had the point 8, 70.83. You're just doing slope formula with those. You don't necessarily have to write the points, but you do have to write this. 70.83 minus 7.32 over 8 minus 0. It is calculator active, so from this point you're welcome to just type it into the calculator. 70.83 minus 7.32 is going to give us 63.51. We're going to divide that by 8 because 8 minus 0 is just 8. And you get 7.93875. You can do 939 or just keep the whole decimal. I'm kind of feeling like keeping the whole thing there. It's not too long. Now, at this point, I don't know that you have to put units with your answer, but in 2, you're definitely going to have to put units with your answer. So I'd go ahead and do units right here. What are the 70.83 and the 7.32? What are those? Yes, but are there only 70.8 people that have a Netflix subscription? Million people. So this is million and I guess we should say subscriptions because many people might be sharing their Netflix where maybe there's more people than just subscriptions. So, million subscriptions per, and then what are 8 and 0 measured in? Years. So, million subscriptions per year.
Now I don't think you can share them.
I think they've cut back
like
on it.
IP or whatever.
Yeah. I think you can like log in on somebody else's once, but if you're doing it all the time, you're going to be flagged. Yeah. So, just totally ruined it, making everybody pay for it on their own. Gosh. I think you can get it cheaper if you got ads. The better one's more expensive.
Overall, the price of Netflix has increased exponentially. At what time do you think it will cost $20,000?
Yeah. You definitely look at it. So, interpret the meaning of your answer in context of the problem. So, he gives sort of like a fill-in-the-blank thing here, right? On average, the blank increases or decreases by blank units per, I think you should have like units per time here from t equals 0 to t equals whatever. So, we're talking about the number of subscriptions, right? So, we could say, on average,
We just fill it in the box.
yeah, if you want, the number of Netflix subscriptions are we increasing or decreasing? Increasing. So increases by 7.93875 million subscriptions per year from, now, if I were doing this, I wouldn't say t equals 0 to t equals 8. I would say from 2007 to 2015. You could probably get away with t equals 0 years to t equals 8 years. Because if you say 0 to 8 years, you really need to say 0 years since 2007 and 8 years since 2007. So I would just go ahead and go back with the straight years for that. You might be able to go away with t equals 0 to t equals 8. Everybody good there? All right, so for the third part, he actually gives us a couple different options of, or for the second part and third part, he gives a couple different things that they might ask you for this. So instead of asking you to interpret, they might ask you to predict using that average rate of change. So what we're finding is like subscriptions is growing at 7.93875 million per year. So you have a starting point and you're growing that many per year if we're looking at this linearly. So when he gives this formula right here, he's telling you that whatever they're asking for equals y sub 0, that's your starting amount, right here, that's your starting amount, plus AROC, which is average rate of change, which is the 9 point or 7 point whatever we just found. And then what's t minus t sub 0 going to be? It won't be for this question. It'd be 6 for this one. It's going to be amount of time since the start. Value. So in this case, we started at time equals 0, right? So if it's asking us about 6, it's just going to be 6 years. Goes right there. But sometimes it doesn't start at 0. So it might be we knew time 2, and they ask us for 6. So that's 4 years that have gone by. So we'd multiply it by 4 for that. So what we'll do for this is they started off with 32 million subscriptions. Then it's growing at our average rate of change of 7.93875. And we're going to multiply that by 6, because if it's asking us at 6 years, then that means we have 6 years that we're increasing at that rate. Every year for those 6 years, your value increases there. So if we just find that in our calculator, we get 54.9525. So I would probably put at t equals 6 years. There are about, or approximately, 54.9525 million Netflix subscriptions. The reason you cannot is because it's asking you for the average rate of change, to use the average rate of change. So you can't plug it into 6, or into the regression that you did, because that's not using the average rate of change. That's using the exponential model. So when it says use average rate of change, you have to do it this way, which treats it like it's a linear function, even though it's not. But you have to do it, and they're gonna this is going to be part B every time. Like they're going to ask you, everything in part B is asking you about average rate of change. So you're not gonna, you have to use the average rate of change for that. Now, as I say that, part 3 here does, oh gosh, why did that do that? Well, can I move that back up? That's annoying. All right. Yeah. Well, you guys saw what I wrote. I'm not going to go back and rewrite it for the sake of time here. But I don't know what else in there. So, for this third part, it says, consider the average rates of change of n from t equals 8 to t equals p years, where p is greater than 8. Are these average rates of change less than or greater than the average rate of change from t equals 0 to t equals 8 found in 1? Explain your reasoning. Okay, so if you get this question, it's asking you about what's going to happen past 8. So let's think about what we've been doing in the first place. This data is exponential, right? And you've got right here at 7.32 is your first data point, and then over here at 8, it goes all the way up to 70.83, and it's exponential data. So that means it looks like this, right? So it starts off growing kind of slow. In fact, I might even need to, gosh, why did it all go away? It's not cooperating with me here. This is 0. Right here is 8. We got 7.32. We got 70.83. We got a point here. We got a point here. I should even make it look a little more curved like this right here. All right. So, my average rate of change, what I just found, my average rate of change was the slope of this line right here, slope between those two endpoints. So when we go past 8, when we look at values past 8, and they're calling it P, where P is greater than 8, so like if I put over here a P over here somewhere, oh, let's move that P a little bit closer, just because it won't show up on my graph, right? So P would be like way up here, right? And if I find the average rate of change from 8 to that point, then I would be looking at like from here to here. Is that going to be steeper than our original or less steep? It's going to be steeper because an exponential keeps getting steeper and steeper and steeper and steeper, right? So, so the way that we want to talk about this is we could say the rate of change of n of t is increasing because n represents exponential growth. It's going to be backwards if it's exponential decay, if you've got the number of net. Like if we looked at the DVD subscriptions, we'd see decay, right? Because, I mean, I'm pretty sure they're not available anymore. But over time, those DVD subscriptions were dropping fast. But this is exponential growth. It is important to put growth instead of just saying exponential. Because if you have decay, then your rate of change is decreasing. There. Actually, it's negative, so it might still be increasing. We won't get into that though. So the average rate of change for t equals 8 to t equals p will be greater than the average rate of change from t equals 0 to t equals 8. I think it helps to draw a picture of the graph there. I don't know if you still have to have the explanation in words as well, but the graph is going to sort of show the grader that you were thinking correctly about that. Okay, so he says down here for part C, it says part C will always ask about some sort of restrictions for our model. This might also ask about how we should or can or should limit domain or range for the model. So there's a lot of things that could be asked here, and on some of the other questions we're going to see another way of doing this, but it's asking about some restrictions. In general, the further out you get from your actual data, the less reliable your data is. If we take population data for Elkin right now, and we use it to predict the population of Elkin in 2200, it's probably not going to be accurate, right? But if we use it to predict the population a couple years from now, more accurate. If we use it to like predict something within the scope of our data, most accurate, right? Like if it's between, in this case, between 0 and 8, is going to be the most accurate for that. For this, it's asking us for which t-value, t equals 6 or t equals 19, should we have more confidence in using the model N? Give a reason for your answer in context of the problem. So we should say we have more confidence in the prediction at t equals 6 years because that t-value falls within the data points we used. For the model. T equals 19 is farther outside the data points used and will be less reliable. They can ask you other stuff here. They might ask, like, for example, a restriction on this right here for your domain. You wouldn't want to go back before 2007 because it didn't exist before 2007, right? So it wouldn't make sense to talk about the number of Netflix subscriptions in 1980 because it didn't exist. So you wouldn't want to go backwards in time. You wouldn't want like in this case, you wouldn't want your range values to ever be negative because you can't have negative subscriptions, right? It has to be greater than 0. There could be all kinds of limits that they might ask you about here for Part C. But it'll be something about when this actually would be useful in real life. The second question is always going to be in a real life context. The first question is more of a naked problem that's just the equations. The second one is going to be in some sort of real life context. All right. Let's see.